Hi, today I'd like to talk to you about how to use your TI-83 or TI-84 calculator to calculate regression models for various graphs. Today we'll be looking at an example from our textbook. Table 1.12 records the low and high daily temperatures observed on 9/9/1999 in 20 major cities. Find the function that approximates the high temperature y as a function of the low temperature x. Use this function to predict the high temperature for that day in Madison, Wisconsin, given that the low was 46 degrees. So to begin this problem, we are going to need to jump into our calculator, and we are going to want to go into our stat menu. Stat's located right under the delete key. Clicking on stat menu and going into the edit list, it allows me to see that I've already entered in my X datas, or my lows in list 1 and my highs in list 2. Once I've entered that data, the next thing I'm going to do is I'm going to go ahead and take a look at my stat plot. To look at my stat plot, I'm going to go second y equals, and I'm going to go ahead and turn my stat plot on. Notice that it is identifying that list 1 is my x values and list 2 is representing my y values. I'm also identifying that I'm using the scatter plot. After I've done this, to help me ensure that I have the correct window, I can go into Zoom and scroll down to Zoom Stat. What this does is it takes my statistics and it puts it into the appropriate window. When I hit enter, it automatically will create this nice scatter plot of all of my data points. Looking at these data points, I can see that it does seem to fit a linear pattern. Because it's fitting a linear pattern, I'm going to use a linear regression model. We want to sometimes use a diagnostic tool known as our regression correlation coefficient, and what it does is it tells us how accurate our linear model is. To turn this on, you're going to go second 0, and you're going to go ahead and jump to your D's and go down to diagnostic on. Hitting enter and enter again turns your diagnostics on. Next, I'm going to go into my stat menu, over to calculate, and down to the option that says linear regression. What your calculator is going to do is it's going to take all of those points and determine the line of best fit that would go between them. Simply hit enter, 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 enter. Some of your calculators will not have all these options, so you'll just be able to hit enter twice. And if I hit enter, it does all the calculations, and it shows me that my linear regression model is 0.97 if I round x plus my y-intercept of 23.01. Now, beneath that, I have two numbers here. The R value is the one we're concerned about, and that's representing our correlation coefficient. What that tells us is it says that our linear regression model is pretty good. This number, if it is close to 1, it's a strong positive slope. If it's close to -1, it's a strong negative slope. But if it's close to 0, it means that the relationship really isn't there, and that you should probably consider using a different model or potentially gather more data. If I take those values, though, and I plug them into the equation, I get an equation that would represent my high temperature with regards to my low for any day in any city. According to the problem that I've given you, you need to plug 46 into x, multiply and add the 23.01, and you get that in Madison, Wisconsin, on this date, if the low was 46 degrees, the high was 67.62 degrees. Now, as always, you want to be cautious when dealing with this data because it may not be consistent from Florida to Wisconsin or from New York to Los Angeles. But in general, we've taken various temperatures and used it to complete this problem. Now, when you're dealing with regression models, it's important to remember that regression models have many types. We have linear, quadratic, cubic, quartic. All of these are located in that stat calc menu, and you can see that if your data points, your stat plot, is showing any of those other graphs, you would want to use that regression model instead of the linear regression. So it is important that you do take that step of graphing those points to ensure that you are selecting the right model. So these are just some of them. These are located in your textbook as well. And here are just a few more that you could potentially have. The nice thing about using your calculator is you no longer have to do it by hand. You can just use the calculator to tell you those values. If you have additional questions, please feel free to contact me and ask me with any of them.